Well, I want to welcome you all for the final session. You are the hardy survivors of the of BMSB 2019. And it does seem like an endurance test, doesn't it? I know for Sung it has to. I mean, but for the rest of us, it's been a fun-filled 3 or 4 days, depending on when you got here. So this panel is going to be very non-technical. We've spent the last 3 days going through technology. A quick show of hands, whether it's 5G or next generation television. How many of you think that technically all we've talked about can be done? Yes, you know, it's going to work. Yeah. Because, well, those of you who aren't waving your hands, I'm not sure what you're doing, because some of you presented. So,
doubts about EMBMS.
Yeah. Oh, okay, well, but yeah, so anyway, so this is really going to be a very non-technical panel, but we're going to just talk a little bit about what we've heard, what we've seen, but we're going to look at it from, a higher level. And so I've got some questions that I've thought of over the last 3 days. Hopefully you folks have some questions, because this is also audience participation, and it'll be a much more interesting panel if the questions come from you folks as opposed to coming from me. But I will kick it off with an easy one. And it's going to be kind of localized. It'll be about ATSC3, because I'm from the US. But at this conference, we've talked a lot about the cooperative development between ATSC3 and 5G. And one of the challenges that I see is that the broadcast standard we're talking about, broadcast standards in general, vary by region and are incompatible with each other. And while 5G, of course, appears to be a completely unified global standard. So the question I would ask all the folks on the panel is, what is the compelling reason for 5G proponents to consider ATSC3 as an integral part of their rollout? And I'll let Mark or Jerry, whichever wants to start. Or
I think there's probably several. Certainly the efficiency factors of a pure broadcast. Efficiency not only in terms of bits per hertz, but at the same time the efficiency in terms of ease of reception. I've come to the conclusion the only reason that a carrier, a mobile wireless operator would use EMBMS is not because it's good, is not because it's better by any stretch. They use it because it's already in the phone. So it seems to me that get ATSC3 into the phone, and you have an opportunity to globalize ATSC3 in the way that no other broadcast standard has been globalized.
There's also a implementation deployment advantage to using ATSC3 in a 5G world. If the carriers want to save money, and rather than building out that last mile so extensively from the carrier to the home, why not just rent the broadcaster bits? The folks at ETRI demonstrated the seamless handoff of broadband and broadcast in an ATSC3 world. And if I'm a carrier and I don't want to spend the money to build out these milliwave very small cells, I'm just going to rent bits from broadcasters, and that seems to be a cost imperative in a real world situation of why you would want 3.0 as part of a 5G environment.
Okay. Yeah, so I completely agree with that argument. I mean, 5G, as it is announced and it is marketed continuously, is not going to reach majority of population in many countries. And this includes US or advanced countries in Europe, because rural areas will never experience 5G as it is announced today. And if there's a try to serve this part of the countries properly, it will not be financially reasonable to do it with 5G. So using that type of combinations in areas where it does not make sense to have one EV node each 200 meters, that's where broadcast has a serious role in 5G.
Yeah, I have a fundamental question. What is 5G? Right, 5G is going to be an ecosystem that's a so-called HETnet, including multiple frequency band and different transmission system protocols all together. So it just keep you connected, right? That's the goal. Like broadcasting is a one-to-many, is one of the perfect way to deliver to mass people for the most watched programs, right? I remember at CRC every year when there's a hockey final days, our president always send an email say, hey guys, don't streaming from your desktop. Please come to the cafeteria, there's a TV on. I said, now you're talking about the TV, because it doesn't matter what to do, that day internet is not going anywhere in Canada. So that's just one example. So I think like broadcasting is one-to-many, and that's different with the point-to-point connectivity. And in the future, important things that keep people connected. General public don't know what is 3.0 or Wi-Fi. They just want the service, right? It's for our technical people to do a better job.
And in this BMS conference, we have heard many things about the advantage of broadcasting, point to the many. But as you know, the DVB-T2 83.2 DTMBA advanced ISDVT has a better frequency efficiency compared to the 5G, 4G MBMS system. But the biggest reason why we should focus on the 5G is very simple. Many people already tried to push the receiver manufacturer to include the 3.2 or T2 chips in their smartphone. But as I understand, if I correctly understand, no receiver manufacturer included mobile chips in their smartphone. Not just only the dongle type of receiver. I know the Sinclair is pushing one of the Indian company to include the 3.2 chips in the smartphone. This is an economic point of view. Technically, broadcasting technology is much better than the 5G or 4G or 5G, but economic point of view, carrier industry much wider, and they have money to control in the market. So I think without connection between the broadcasting industry and mobile broadband industry, I'm really negative for the terrestrial, especially terrestrial broadcaster future. Maybe 10 years later, no more people watching the terrestrial TV. For me, in my home, I'm just normally turn on the TV, and then I'm watching my cell phone, both of them. So this is very serious. We should be very serious to seriously consider the future of our broadcasting industry.
Yes, I agree with Song. In Brazil, we have a service for 1 seg for mobile devices, but it's very difficult to find the device with 1 seg today. Only old models with no high technology, with small screens. And I think the broadcast has a very good coverage, but the market doesn't agree with the technology. And in my home, for example, I received the TV over the air with better quality of the internet, but it's free. I think it is the most important point in some countries like Brazil. The TV over the air is free, and in the other ways we need to pay I think it is a big difference of the broadcast television.
I just wanted to add one point. You can't separate the technology from the spectrum either, because it's a matter of proper utilization, if you will. You know, what are the fundamental differences between, you know, 24, 28 gigahertz versus 600 megahertz? 5 and 600 megahertz provides for deep indoor penetration. You know, so part of the battle I think that we have is a regulatory battle, and in fact is it is about economics. Every day we are reminded at work that it's all about the dollar, but in a very serious way, the earnings of a publicly traded broadcast group is dependent upon providing a level of service that meets the expectation of the consumer. So clearly, the better reach, the ability to you know, to have every device. I showed that one slide 2 days ago from Bloomberg News where for the first time, more time is being spent on this device than television in the United States on the average. So it says to me, if our business of broadcasting is to continue, we need to be on this device.
Let me also make a footnote that there is a place for capabilities that are built into ATSC 3.0 that cannot be replicated in a broadband world. Think of an emergency. Think of a tornado or a hurricane or a fire. What's the very first thing that collapses? The cell phone network, right? Because the one-to-one, if one tower goes down, it's overloaded, too many people trying to get, the emergency responders can't get one-to-one communications, but the built-in capabilities of ATSC 3.0 are spectacular. Rather than just seeing a warning crawl that there's a tornado coming, wouldn't it be great to see the live Doppler radar? Wouldn't it be great to see what the weather looked like? Wouldn't it be great to see evacuation routes? Wouldn't it be great to see emergency shelters? Wouldn't it be great to hear it in multiple languages? Well, all of that is built into the 3.0 standard that cannot be replicated in a broadband world.
Well, actually, Jerry, that's an interesting point because I think how many of you yesterday around 5 o'clock got the emergency message on your cell phone? How many of you that aren't from Korea were able to read it? It's interesting. It actually made me send Luke Fay at ATSC a note because it seemed to me that one of the features that every time you set up a device, one of the first things it asks you is your preferred language. And you would think that built into that device would be the ability, especially for emergency messaging, to take that message and translate it into, it's a text message, translate it into the preferred language that is recorded on that device. So I suggested that as a work item for ATSC 3. We'll see if it goes through. But some interesting points of view here because I think it sort of depends. We've talked a lot about convergence, but convergence seems to be dependent upon where you're from and how your legislative or your license granting authority looks at things. I know here in Korea we were talking. ATSC 3 is basically UHD television delivery service, and it seems to me that one of the challenges that you face here is that your governing authorities don't fully understand the capabilities that are available to them within the standard. So, Sung, if you would talk to that, but Jerry, think about this: is this also an issue that we would face in the United States of convincing our legislature that there's more to this than just a new television standard of that as they understand television? So.
Okay, let me first explain about the Korea situation. Many people international people just misunderstanding about Korea situation. Our government we have two departments. One is the regulation department, similar to the FCC. There is another government who wants to promote of new technology. They are already completing some new technology. They are understanding what Aitken 3.2 can provide, especially emergency alert, more capacity, more efficient use of frequency. They all understand, but we have a much more complicated issue. You know that why we should start ETRI 3.2 broadcast in the world first. Our government assigned 700 megahertz band, 5 channel for the UHD broadcasting. So with this region, our government is a little bit hesitant to invest money to the broadcaster side because they already assigned the frequency itself, most expensive frequency itself to the broadcaster side. So we are still making the kind of conversation how to promote the ETRI 3.2, especially kind of a multiple channel service. I mean, in our regulation, there is one sentence, the stream should be 4K quality, 4K resolution. So we are just trying to remove the sentence, but it's almost impossible because of a political issue, not technical issue. So but we are still trying, and also we are still having the conversation with the government and industry and broadcast all together to provide a multiple program or another thing. But recently, in my understanding, broadcaster has also a little bit different opinion. Just a couple of years ago, they also strongly wanted a mobile and multiple service, but last year they made a big, they lost big money in the broadcasting area. So they don't have any more money to invest in the multiple program on mobile. We are very serious situation. And also many Korean broadcaster or broadcasting related people are just looking at what US broadcasters are doing for the future. We are just want to learn how to make money from the ETRI 3.2. This is quite important to the Korean broadcast society. If you are very successful to make money in the US, maybe our government people or political people may change our current regulation. Maybe to remove the one sentence, 4K is 4K requirement. Yeah.
I'm going to challenge the question that Bill made because I strongly disagree that the challenge of broadcast industry is to convince or to make regulators make the framework that enables convergence. You have to convince first broadband industry. I mean, you can convince FCC, I'm sure. No matter who is on top of FCC, not even if you think you have the worst person on top of FCC. What you have to convince is broadband industry, cellular industry, that convergence is a benefit for them. Because unfortunately, so far, they just even do not look at us. Broadcast industry has tried to approach cellular, 3GPP, etc., with little success so far.
I actually agree with that, but we have to challenge this on multiple fronts. It's not just one. One of the most powerful forces in the world is the force of inertia. And that's government inertia, it's business inertia. We fight this in the United States to convince other broadcasters who are used to getting their money from advertising and now getting money from cable companies and satellite companies for programming rights. They don't think in terms of the capabilities that are now open to them because of ATSC 3.0. Businesses that they've never contemplated before. So this inertia in our own colleagues and broadcasters, and then there's the inertia of government. And to your point, we have to convince the regulators who know what they know. So our challenge is to educate them on what they don't know. And so when they make new regulations, just this morning I was drafting comments proceeding at the FCC where they're thinking about rules in terms of what ATSC 1 was and they haven't contemplated what ATSC3 will do. We have to remind them of the capabilities of ATSC3 so they don't make mistakes in writing new laws. Similarly, with respect to 5G, as we look at ways to most efficiently use the network or use the spectrum, we need to convince them that don't do anything that hampers broadcasters' ability to grow and use 5G. So there's some educating of regulators, there's some educating of our colleagues, and to Pablo's point, there's educating of the broadband. They need to know financially that it's in their best interest to rent our bits because it's business, as Mark has often said, it's the dollar that drives business.
And one other point is that this is truly this is a global battle. You know, Jerry in particular is very involved within the ITU. And the spectrum usage gets defined on a global level. I mean, in Brazil, for example, you have CTEL, which is the hemispheric arm of ITU that covers North and South America. There was a tremendous fight where just a mere 4 years ago, the United States, under a different FCC leadership and a different administration, had the view that all of the UHF spectrum should, in fact, be as a minimum allowed use by IMT, International Mobile Telephone. A successful battle was organized. Brazil played a critical role in that because the ITU, in fact, defines and dictates and tries to coordinate on a global level, mostly to the success of operators within various bands of the spectrum. And so I say this because recently the activity inside of the ITU, the presenting of ATSC 3.0 as a global standard for acceptance by the ITU, taken up by ourselves and staunchly supported by Korea, is one of many important steps that are required. So, you know, we have mostly engineers in the audience, but I'm always reminded that engineering that may be your primary occupation, but the engineering that you do straddles and goes into other areas of involvement and engagement, and it's a responsibility of engineers to inform those above them in management of many things, not just technical performance.
Hear, hear.
Yeah, I think just add a little bit. It's right, like convergence meaning different things to different people and different definition, and even just the word broadcasting have different meanings. Because you said, okay, 5G broadcasting. Well, some people thinking is, okay, like we have a standalone broadcasting system in the 5G ecosystem. That's one way to do it, right? Another people said, yeah, 5G system should have broadcasting capability. They can do one-to-many from the 5G system, for example, MBMS type of thing. They can do broadcasting. But I think that at the beginning, the broadband industry really want to have the broadcasting capability. But it will be later. See how things going. They probably will have interesting for broadcasting system, right? That is all, like we all talking about how to more efficient use of the spectrum, right? If you really want to efficient use the spectrum, regardless of what kind of service, have an integrated service on your spectrum, you better combine broadcasting and unicasting and multicasting all together, because that's really the way to most efficient use of the spectrum. Like you can even, for example, during the day, there are not many people watching the TV, but for broadcast, more important money-making probably is prime time advertisement, right? Maybe during the day you should surround some spectrum resources to the unicast because that's most business traffic. Then at the prime time, you maybe gain more frequency back to do your 4K or 8K or whatever, AR, VR. So that is more dynamically use of the resources, depends on the usage requirement and needs. Forget about the what system, what's the delivery mechanism. Like it's just thinking about massage all the service together and based on the demands, timing, and the requirement.
One question that was asked several times, I know that because I asked it a couple times, was the simulations and theoretical work that goes on typically starts with AWGN, but many times it ends with AWGN. And we know in the case of 8VSB, AWGN and coverage and spectral efficiency was in fact the most and the primary objective, and look where we ended up. It's important to understand the use cases and the environment that is produced in those specific use cases. And a good example I was relaying a little bit earlier is we've been very involved in India for lots of reasons, but imagine, if you will, more than 100 million people all at once going to their unicast device to watch, I know it's not everybody's favorite, but to watch cricket, the IPL. And the network dies. The network dies. Now in India, you had a Reliance Jio built out an all 4G LTE eMBMS enabled network, 100%. And the reason is that they developed a business model based and dependent upon certain assumptions about the broadcast mode of eMBMS and the efficiency and the ability to deliver programming. Well, in the real world, when they deployed that network, what they found is they only had 30% of the efficiency that they expected, because guess what? People watch this stuff in their home. And 2.1 gigahertz is not the proper spectrum if one is looking to reach a consumer in the home. So context is important for everything. And so, as the young engineers in the audience apply themselves, I think that you need to apply yourself as well in the context of thinking about how's this technology going to be used, who's it going to be used by, where are they located, and what are the circumstances that impact the overall experience, not just the efficiency, but extend that to the notion of what frequency band is it going to be used in. There's a world of difference. For example, we hear 5G. What is 5G? I'm always asking myself that, because I think, in fact, it is, for me, all about headnets. It's all about interoperability and so forth. But it certainly, is not the case that I'm going to use 24 or 28 gigahertz spectrum to reach automobiles on the move. It just isn't going to happen, at least in this lifetime.
Yeah, I have another comment back to you. You are just emphasizing the frequency band for the penetration, especially indoor, like something. But we broadcasting are based on the high power, high tower. So in Korea, even if we are using the latest technology, 83.0, it's still difficult to go inside, deep indoor. I don't think, I believe the UHF band is much better than gigahertz band, but still, without the low power, low tower concept, still very challenging to go inside, deep indoor reception. So if we are consider the mobile reception using the broadcasting technology, the best solution is a low power, low tower, or medium power, medium tower, the dense SFN. This is the only solution. Maybe it is more important rather than frequency efficiency. Otherwise, very difficult to reach the indoor or mobile receiver.
So what I'm hearing there, Sung, is that one way or another, somebody's got to build out this infrastructure. Whether it's and the case that we're trying to make at this point is that based on the use cases that we're talking about and the efficiencies, the broadcast, the traditional broadcast group is probably the better choice. Now, Mark, back to a statement that you made about, or that, no, actually that Pablo made, but we all agreed with, is the conversation with the broadband industry to get them on board with this. It would certainly be helpful if the broadcast industry could unify and approach, because again, we're talking about the 5G proponents, which is a global standard, and what we're trying to bring together is a group of disparate broadcast standards to tell a common message to an industry that is that needs to hear this common message that yes, the broadcast layer, if you will, it's better to do it that way than to try and build your own. Is that a realistic potential? I mean, I remember David, one of the first question he asked was that when FOB-TV came together, we were unable to create a global broadcast standard. I pushed back and said we actually did it. We were unable to get it adopted, but I believe the standard itself was global. It was certainly a lot of global participation. But is it practical for the broadcast industry globally to unify around this? Pablo? Here you go.
Yeah, there are two sides here. The technical side, I don't think that it is technically complex to have a multi-standard device. I mean, I don't see that this is the main blocking factor. I mean, 5G new radio or making a device work in the millimeter wave is a huge challenge. And if you want to sell it by $500, this is a huge challenge if you compare it to the fact of integrating 3, 4, or whatever standards inside a chipset. So this is not really a challenge. The other aspect, which is and by the way, sorry, the meeting point of those technologies is clearly IP or any similar initiative, because DBB finally understood that they should go to IP, and DBBI initiative is mainly linked to that convergence. But on the non-technical side, what is difficult on a global basis is to find a common point of view of broadcasters from different regions. Because if you look at the business model of US broadcasting, if you look at the business model of broadcasting in Brazil and broadcasting here in Korea or China or Europe, I mean, you need to find the common baseline of the business model to have a common view of your business. Because in fact, here what we have is one view from US, another view from Asia, another view from Europe on the business point. So, and by the way, cellular operators in Asia, in Brazil, in Europe, they have a common, well, they have the lack of having a common technology, but more important, they have a common view on the business model, which is the important part of it.
That's precisely a great point. People and companies act in their economic self-interest unless there is an economic externality. And the economic externality in this business is whether or not the government mandates a certain standard or, for example, mandates chips in phones or chips in devices. So if you're a telco, they have a common message, they have a good international lobbying organization. They're all over ITU in terms of standards. Broadcasting, and at least the use of broadcasting in our bands, use many different standards. There's DVB in Europe, there's ISDB in Japan and in Brazil, there's ATSC 1 and now 3 in Korea and the United States. The Chinese have their own standard. We have multiple standards that some of which act better in a 5G world. It's more compatible in a cellular environment. So how do you convince a broadband operator, how do you convince a telco operator to include chips in phones? One, you get the government to tell them to do it. If the government's not going to do that because they want the marketplace to decide this, right, then you have to make it in their economic self-interest, right? One of the ways to do that is to tout the emergency capabilities of ATSC3 or a similar service so that from the ground up, people demand certain elements. And so that's one way to use the one camel's nose under the tent, is to use the inherent capability of 3.0 to say emergency notifications or emergency information. That's one way to get it into the phones. A second way is to have the government as a buyer. The government itself buys telephones, right? It could go to the carriers and say, we'll buy your phones, but you have to have this ATSC3 technology in the phones. That's another way to do it. But unless it's in their economic self-interest and unless the government mandates it, it's a very difficult proposition.
And I guess I would argue that FOB TV just hasn't been successful yet, right? So failure is one thing. Sometimes success takes a very, very long time. I'm a testament to that fact in how long it's taken the United States to adopt OFDM. But I would argue that by the very nature of the carriers, if the carriers understood and the carriers could be convinced of the efficacy of using ATSC3, and by the way, I very rarely actually use ATSC 3.0 as my lead. I convert the conversation to next gen, and the reason is that ATSC 3.0 for me is Korea. I think the United States ought to be ATSC 3.1 because there are substantive differences in the standard. And what that points to is that we have an evolvable standard. And what's important about that standard, well, I won't say the most important, but important, intersects a lot of points we've made here, even about the notion of language. You have a universal entry point with the bootstrap. You have the ability to signal in ways that has never been available in a broadcast standard. As I said, 14 million plus different possibilities between the root and the seed of the bootstrap. So in 10 years, my dream is that there won't be the need for a 3GPP because, in fact, with SDR, your point is absolutely on target. SDR makes the generation of different waveforms a relatively easy and insignificant task. Certainly, as time progresses, it becomes easier and easier. And if we move towards an environment that gets born out of 5G, which is an environment of the cognitive nature of radio being identified and a relationship between an end device and the network device, I see a day perhaps 10 years away where in fact you have AI-driven waveforms being generated on the fly based upon a relationship to an end device that's dictating the specific needs of different waveforms, different coding techniques, et cetera, to provide a designated task. And then it comes back to bits need to be context aware. Context awareness provides a means to identify how that path needs to be taken across the multiple networks that become intertwined with 5G and beyond.
What I hear you saying is it won't be a Microsoft operating system.
Yes.
So, well, you bring up an interesting point. Oh, by the way, if you have a question, please raise your hand, because but I can go on all day, as can most of us. But it's
You don't want us to.
no, really, you don't. But I haven't. So it sounds to me like there's a couple of stories to tell here. One is I look at headlines. I was at the Detroit, the Pearl Group presentation in Detroit, and I've heard 5G presentations about some of the use cases, and they seem to be sort of working on the business to business as sort of the low-hanging fruit. I've got 5G people talking to me about how to use that to replace camera cables for remote shots and my production truck. And I've got Detroit, the folks from Pearl and Sinclair talking to the automobile industry and using ATSC3. So this is us, as this is the broadcast going after a somewhat different audience. So that's one story we have to tell. And then there's the other story we have to tell is what about the next gen television makes it essential to the people who just use television? And so who wants to take a stab at answering one or both of those?
I think there's a multiplicity of use cases. Some are B2B, some are consumer uses. We tend to think of television as we've always thought of television, a linear service that's provided to us. But now your children watch television on the wall, on their tablets, on their phones, all at the same time. So there's different usage patterns. We have to start thinking, instead of the traditional way of television, on business to consumer uses. Mobile, that we've abandoned in the United States, that we need to get back. That's a personal use for television that we haven't had certainly since the analog days of Sony Watchman, right? Looking at Lachlan there. I still have my Sony Watchman, it just doesn't work anymore.
Get a set-top box for it. You get a set-top box for it.
Okay, set-top box. But there are other consumer uses. There's distance learning that is a one to an individual that has a capability built in. There's VOD and OTT uses to the individual that's enabled by 3.0. There's offloading, so that if you are a Netflix or a Hulu or an Apple TV, and the Black Panther movie comes out, and you want that cached on somebody's home device so they can watch it at their leisure, right? Now that is a business to consumer use. So it's a non-traditional linear television consumer use, but there are consumer benefits, and that just puts aside all of the quality and the enhancements of the things that you would expect television to do and evolve to. But those are consumer uses aside from the business uses. We don't want, and we certainly at OneMedia and our parent company at Sinclair do not want to be the entity that justifies all potential uses. As many people are out there, as many people that all you engineers thinking up use cases, we don't want you to be limited to do that. We have some ideas we think are, as you say, Bill, low-hanging fruit, but there are as many uses as there are people out there.
All right. So I thought there would be more. Sorry. So going back to this idea of offloading bits, I think Jerry, was you said, or Mark, one of you two said that it, convincing the broadband to rent the bits from us. It seems to me there's almost a trade arrangement there, though, since when we looked at the demo in the on Tuesday, where we watched the broadband network take over when the broadcast network went away. I get a little concerned about the idea of the renting, because it sort of takes me in the United States to retransmission consents, which is a very a difficult, conversation to start with the broadband industry.
Well, we don't want it to be a fractionalized marketplace. So we've developed this consortium, this Spectrum Co. What Spectrum Co. will do is all 1,500 or 2,000 television stations in America, if they're all signing up in part of the 5G or part of the next gen operating process, they're going to take a little bit of that 6 megahertz, right? Maybe just a slice of the capacity in a 3.0 world and give it over to Spectrum Co. Spectrum Co. will then be the wholesaler that will be the interface between the broadcaster and the telcos that want to offload. And so it provides a way to, on a regional basis or a national basis, to provide a way to have a CONUS coverage, a data coverage. That's our theory. That's what Spectrum Co. is going to do. Broadcasters are not very good at thinking outside their own box to these new business models. Somebody's going to have to provide that service for them, and that's why we've developed these things. But this Spectrum Co. But to your point of renting our bits and whether that's a transaction that the telcos are going to be comfortable with, I come back to, if it's in their best interest, they're going to do it.
Anyone else?
Well, then I'll add to that. Sorry. I want to go back to Jerry's presentation that was made 2 days ago, and it struck me. It struck me in a way that it hadn't struck me in a long time, and it's not because I hadn't seen it, but anybody who saw Jerry's presentation and sort of clung on to the fact that all of the bits that we emit, that are committed to programming other than our main channel are valued at 0.001 cent per gigabyte delivered. Think about that. And then compare that to that big, fat red ball that popped up on the screen of $2 a gigabyte that the carriers get for delivering content to a consumer. That is a 200,000 to 1 ratio, pretty darn big ratio. And all we have to do is move that decimal point one place, and we double the revenues of the television side of the business that we do. So there is incredible value that is locked up. And I tell people, think of people who don't think about broadcast, they think about this phone and they've got this one-to-one relationship, and I say, think of broadcast as simply having the X factor. And that means that for every gigabyte that gets delivered by the unicast provider, multiply that by the number of people inside of the circle that can in fact receive that same signal, and that's the X factor. In a marketplace of 1 million people, deliver once, and I'm not suggesting that deliver once is the right way. I'm sure the carouseling techniques, not everybody's device is on 24/7, but with the odds of 200,000 to 1, my bet is that it's pretty easy to deliver content to that marketplace, whether it's automotive or books or education or entertainment, that there are business propositions there. And as Jerry said, too many broadcasters think as televisioners and not broadcasters.
I have a very simple comment. Just ask you to sell your bit to the other business partner. Basically, your signal should reach the terminal, targeted device. This is quite important. This is the main drawback of the broadcasting area. I just want to say again, currently our network topology, I mean the high power, high tower, still very difficult to reach the terminal. So you Sinclair have a big, I know the big plan to install the many SFP, not only just high power, high tower, but also the very low power, low tower, several things. So, but it requires a big investment money, right? So if you are paying make money after the investment, I don't know what should we do. I said, yeah, you remember I said, many Korean broadcasters just watching and looking at your Sinclair or US broadcast people. We just want to see how to make money from the broadcaster.
Well, Sonny, in September, part of that answer will be known by many. There is, in fact, a contract for initial delivery of 100 what we call broadcast radio heads. And a broadcast radio head looks very similar to that LTE radio head that is mounted on the side or the base of relatively low towers. There's a telco operator in the United States who has placed an initial order for 100, contingency for 1,000 based upon initial acceptance of that 100. And in fact, we are investing in building out the infrastructure for a highly distributed network. Because you're absolutely right. It's that typical, we see the TP of the high tower, high power, and then you get the traditional SFN, and it starts looking like a circus tent. Well, what we're talking about is raising the signal floor universally. And that's essential because the same limitations for broadcast are the limitations that a telco operator designs, which is what is my cell edge coverage. And typically in the unicast world, they're designing for the coverage based upon the maximum, which is a fairly minimum amount of power that this device can actually report back to the base station with. So as you lift that floor upwards, what in fact you do is, and it probably wasn't well represented in my slides, but it is in fact the multiplier in terms of the bit capacity, bits per hertz, of the spectrum that we have. So ask me in September, and I'll give you a much better clue about what investment's being made.
So Mark, would we be better off if we stopped thinking about the services and just started thinking about it all as bit casting?
Let me answer for Mark.
Yeah, I want to answer as a broadcaster, as a publicly traded broadcast company.
To your point, we have to start thinking of ourselves as an owner of a great, big, giant data pipe. Television is one slight straw in the data pipe. It's just one type of data. The quicker we understand that we are in the same business as the telco, while we are limited by having one-to-many, we have the efficiency of having one-to-many, but we are using a great big giant data pipe. And as soon as we understand that we are a data platform deliverer, the better off we're going to be. We're going to understand the multiplicity of businesses that we can be in.
Yeah, I fully agree. It's a data pipe, but unfortunately, other than FCC in US, now the other spectrum authority actually allowed to do data casting using broadcasting band at the moment. That is a big problem, for example, in Korea. You just cannot do it. Can you do data service and make money using broadcasting band?
Not Brazil.
No, yeah.
Not yet.
Yeah, because that is a big problem because just last Friday, CRC did the first in-house 3.0 demonstration. So we call in our spectrum authority and CRTC come in and they were looking, and I told them, 2 days ago, 28th of May, FCC starting accepting application for 3.0. So our CRTC guy almost fainted. He said, really? and he said, so what's the difference? I said, well, I tell you too. First, you got to allow multiple programming. Right now in Canada, just in Korea, one TV program per 6 megahertz. That's crazy, but that's 30 years old thinking, but still there. Second was you got to allow IP data casting, right? Even you collect a revenue percentage, you got to allow to do that. But those kind of regulation is not in place, at least in Canada and many other countries. It's some time to change.
You made a point earlier that what the marketplace needs to do is get to a place that yields the highest and best use of spectrum. Governments are the least capable entities to determine what the highest and best use is. Limitations in Brazil, limitations in Korea, limitations in Europe on what you can do, limitations in the United States. We still have a requirement that we have to provide a single over-the-air, free over-the-air television service in order to keep our license. Fortunately, we were able to argue to the government, and I spent 3 tours of duty at the Federal Communications Commission, and they are not good long-term thinkers about things like this, but we were able to convince them to let broadcasters do other things with our broadcast spectrum. The quid pro quo, the thing that we had to give back for that, is a relatively minor. We have to pay a 5% fee of our net revenues that we get, or is it gross revenues? Revenues that we generate from non-television services, we have to pay that over to the government in exchange for using it. That's a small price to pay from our perspective to be allowed, as Yiyan said, to get to the highest best use so we can use our spectrum the way the marketplace wants us to use it.
Yeah, and in addition to that, there's a discussion, or there has been a discussion in the last decade, at least what I know closely, which is the Europe case, between if a broadcaster should be a content provider plus owner of a network, owner of the spectrum, etc. And finally, at least now, the decision has been that broadcasters are content providers. And many broadcasters in Europe, they're just getting rid of the infrastructure. So the concept of operator, network operator, is in place in many countries, especially in the terrestrial countries in Europe. So that makes that use case, I don't know if difficult, but different. There will be those operators, network operators, which are not traditional broadcasters. They just simply they are tower companies. So this is where the business could be related to this bid casting or whatever you want to call it. But I don't see BBC as an IP provider.
Sorry, I just wanted to go back to some of the comments about economic self-interest. I thought that was a very good comment. And I wondered, Jerry, you said about how when the US allowed you to do other things than television, you had to give back 5% of the revenue there. I wonder if one possibility might be for broadcasters to give back some of this unlocked potential revenue to other parts of the ecosystem to grow it. For example, if network operators aren't getting more data going through their network by using broadcast, but they're getting something back, they might be more interested. I know terminal manufacturers, for example, might be, if there was some revenue sharing opportunities there, they might be more interested to put devices on phones, because if they can spend $10 putting a chip in a phone, but they're getting back $1 a month from that user, multiplied by the number of users, they can see economic self-interest going to work there. I'm not a businessman. I don't know whether that's even possible, but I'd just like to hear the panelists' thoughts on that issue.
So businesses take their assets and maximize the profits associated with those assets. The asset that a broadcaster has in the United States is a license to use, a fairly stable license to use 6 megahertz of capacity. We, broadcasters, through ATSC, have figured out a way to slice that 6 megahertz in a way that has a multiplier effect, that we now can use it more efficiently to provide what used to be just one television signal for 6 megahertz. Now we've squeezed that down so that we, depending on whether it's standard definition or high definition or 720p or 1080i, we figured out a way to slice it so we can use a little bit of that spectrum and still deliver the service that people have come to expect. Now we have all of this excess capacity to monetize. So we have this asset that we want to monetize. We're not good yet at figuring out how to do that because for a half a century, what we've been limited to is monetizing linear television. For the first time, it's like being Dorothy in The Wizard of Oz, and she lands in the house in Oz, and it was all in black and white, and suddenly it's in color. Our eyes are opening now to multiple possibilities, and to your point, Lachlan, one of those possibilities is going to the carriers and say, hey, carriers, we got this big chunk of spectrum here. We're willing to share that with you, pay us some money for it, and now you can use it. There's a whole host of ways we can monetize it, but we have this asset, and because of people like you, engineers who have come up with a way to squeeze down the use of that spectrum so that we can, in a multiplier effect, use it, that's the benefit that we're trying to accomplish as a business use case.